So try downloading the file. I have put it as a zip file in the chat window also, and also this link. You can click on the link and you can check. Okay, Sushant, check again. You should have access. Okay, so let me just explain what is there in the folder, and then you can, when you go back, you can try out these things at your end. So there are few papers initially. So one of the papers that is, let me share my screen. So if you look at this folder that I have shared with you all, okay, there are some papers. The first one is the original Barron and Canny paper, where which became a seminal article where the idea of mediation, okay, moderations, how it works, was talked about. So you can keep that as a reference read. Then I have given you 3 papers of mine, which are about moderated mediation, okay, and we will be looking at data of one of these models. So now these models should be familiar to you, okay? So you can look at this variable which moderates one path, okay, from the mediator to the outcome. It is also moderating the direct path, but the moderation of the direct path is not moderated mediation. The moderation of this path is what will lead to the moderated mediation model. There is another paper, and this is the data that we are going to do in today's, we are going to do now, okay? So this was a paper that we published, and here we are going to look at, again, you see this variable, okay, is moderating both the path from X to the mediator and also from mediator to the 2 outcomes. So it is the same moderator moderating both sides of the mediation model, okay? And then there is one, again, another reference read. So you can again look at this diagram. So you would see here again, there is this kind of a moderated mediation analysis that has taken place, okay? Right. Now, what I have done is I have shared with you, as I mentioned, I am following this book, and the file, the way to solve this in the demonstration in the class that I'm going to do is basically the first edition of the book. Okay, so there is a macro that has been created for SPSS. The macro itself has undergone many changes, so it is now in its 4th version. What I have done here in this folder is I have shared with you the macro here. Okay, this is the macro.spd file, which is the 2nd version. So it is not the latest version. Okay, so this is only for demonstration purposes. I will strongly recommend you can order this book for your institute library. This is for our analysis, for our work. We are going to work with this process macro in SPSS. Okay, so let me show you what is the problem that we are going to look at in our session. And as I mentioned, I am having this paper as reference. You can go back and read this paper also in detail. So I have taken a part of the data that I used in this paper. So the model that we are going to test is, we have an antecedent variable. People who are familiar with OBHR discipline, we have a construct called as perceived organizational support. So the individuals respond how much do they believe or perceive the organization being supportive for to them for their needs for the work. So we are hypothesizing, I am hypothesizing here that affective commitment, individuals' affective commitment mediates the relationship between perceived organization support and organization citizenship behavior. So the argument here is that people who believe that the organization supports them are more likely to engage in citizenship behavior, another OP construct. Okay, they will show greater helping citizenship or helping behaviors. Okay, and they will be willing to go out of their roles to help to do things for the organization. So that is the direct relationship, and I am arguing that what explains this is basically the commitment, the emotional, the affective commitment that they feel towards the organization. And this was the data that we have. This was a nurses data. So we were talking about in this research for a nursing, in a nursing hospital context, how would this work? Okay, so that's the first hypothesis. Now, the second hypothesis is with this mediation, we are hypothesizing that there is a construct called a psychological contract breach. Okay, so that means every employee, so in this case, nurses, when they start working in hospitals, there is a psychological contract. There are certain conditions that they believe the organization would fulfill. There is a kind of a contract that is made. Now, if there is a contract breach, if the individual believes that there has been a contract breach, it will moderate the direct relationship, first of all. So we are saying that the relationship between organization support and citizenship behavior will moderate such that, okay, this is how a moderation hypothesis is framed, such that the relationship will be more positive when psychological contract breach is low, which is quite intuitive. If I believe that there has been a contract violation, okay, the relationship between POS and citizenship will be weaker. And if there has been low psychological contract breach, then the relationship will be positive, more positive. And then the third one, so this is the H2 is the moderation hypothesis, the direct path moderation. And now comes the conditional process. So what are we saying? We are saying that psychological contract breach will moderate the mediated relationship. Please look at the wordings here. Here it was directly will moderate the relationship. So we are talking about the direct relationship. Now we are saying it will moderate the mediated relationship between POS and OCB via affective commitment, such that this relationship will be more positive when psychological contract breach is low. So we are saying the mediated relationship between POS and OCB via affective commitment will be stronger, more positive when psychological contract breach is low. Okay, so the indirect, not just the direct effect, will be stronger when psychological contract breach is low. Even the indirect effect will be stronger. Okay, so it will explain, the process can be explained much better. The indirect effect will be stronger when the psychological contract breach is low. Okay, so I have given you this data file. Okay, this is the data. Okay, you have gender, age, qualification, and experience as the control variables, and then I have just given you the aggregated variables here. POS, AC. POS is perceived organization support, AC is affective commitment, OCB is citizenship behavior, and PCB is psychological contract breach. There is a file in this folder, data1.docx, which actually shows you the scales. So it was not just unidimensional, as in we used multiple items. So And these are the references. Psychological contract breach was measured using these items, and so on. Okay, so you can actually just go over the paper or this document. So this is showing what I have given you is just the aggregated variable here. Okay. All right. And then there is a data file, data.sav, which is the SPSS data file. Okay. This is the data file in which we are going to work. Okay. So let us come to this data file, everybody. And
Professor, sorry to interrupt you, but we are unable to access the folder.
still, okay, let me, okay, let me just check. Okay, please tell me if it is accessible now. This is the link.
Yes, Professor, now it is accessible. Thank you so much.
Okay, good. Okay, so take a minute, everybody. I'm waiting for you. You can download and unzip and you can see the files. Please use these files for your learning purpose, okay, especially the process. Uh, this is for your, don't pass it on, because as I said, the latest version is different. I'm just, if you buy the latest book, this process would not even be relevant. So this process is relevant with the first edition of the book that came out. Okay. Uh, I have created equivalent scripts in R, but anyways, we don't have the time to look at R here. So we'll look at SPSS. And okay, so we have this data now. Everybody open and you can so yeah, I'm moving ahead for benefit of everybody. Okay, so we have all these variables with us. We have our 4 control variables: the demographics, okay, age, qualification of individuals, their experience, and then the 4 POS, AC, OCB, and PCB. Okay, and then I will tell you what have I done with the 3 remaining variables. So these are the original. In the Excel file, you will find only these 4 variables. Okay, so the first hypothesis that we want to test is we want to go back and look at the mediation hypothesis. Okay, now Barron and Kenny, if you read Barron and Kenny, he talks about Barron and Kenny, they talk about 3 initial conditions before you actually test mediation. They say that, well, you should test the relationship between the antecedent and the mediator. So you should test whether X is related to M. Then you should test whether M is related to Y. And yes, the first condition they say is X should be related to Y in the first place. Then only, because if there is an effect between, there is a relationship between X and Y, then only it makes sense to test the process. However, this thinking has been challenged now, and people don't research. If you read today literature, even if there is no, the total effect may be non-significant. Okay, the total effect between X and Y is non-significant. Today, researchers still say find use of testing the mediation. So they still find use of testing the process. So the point that I'm trying to make here is, even if the total effect, when you say, so Barrett and Kenny said, well, my POS should have a relationship with OCB. If not, I should not go ahead and test the mediation because there is no total effect. Okay. But now what we say is, well, your total effect may be non-significant, but still it may make sense to find out what is the process through which this can positively impact, what is the process through which it can negatively impact. So people now don't give too much of importance to the first condition, which was the total effects condition, but the other two conditions still hold. That is, my X should be related to the mediator and the mediator should be related to Y. So that is something that we should be looking at. Okay, so now what we will do is we will test this using a normal regression, and I will show you how to do the equivalent using the process macro that has been given in this. So the first thing is we are doing normal regressions, okay, the simple thing. So we'll go to analyze and then linear regression, okay, and you will have a window like this opens up. We select our controls, okay, so the gender, age, qualification, experience, we use these, okay. In case you are not interested, you again control variables, it has to be theoretically driven. I am here including them, but if you in your research you do not find them to be useful and theoretically relevant, you should not be doing it. Then we are looking at the relationship between the mediator and the antecedent. So the mediator is affective commitment and the antecedent is perceived organizational support. Okay. And then statistics here, there's nothing much we want to report apart from the optional already done things. So we just let it be as it is, and then I paste the syntax. So not many of you may be aware that SPSS also maintains a scripting platform, okay, where you can keep storing the commands that you are running. And this is what I typically practice and I recommend to all researchers, is because it gives you a log of what are the commands you have run. Okay, so and you can give comments here. So I'm saying I'm doing the regression of AC. Okay, I'm doing the regression of POS to AC. Okay, so this is the regression that I am doing here. Select this and run this. Okay, so this green triangle here shows you run selection. Okay, so when you run this, you will get an output here which shows the R square is 0.45, that is 45% variance explained. And this is the F of the regression. The F of the regression is significant, which means that there would be at least one variable that would be significant. We go down, we look at the controls, not many are significant. Actually, none of these controls are significant. However, our POS, okay, the variable of our interest, which is the X variable, okay, is highly significant. It is significant at P less than 0.001. Okay, this is how you write Do not write in your research paper P is equal to 0.000. Okay, that is wrong. You should write P less than 0.001. So the first condition of mediation is satisfied, that our antecedent is related to the mediator. Let us do the second condition. Okay, let us look at now our outcome OCB and how is it related to the mediator. Okay, so that is, and I paste the syntax again. So you see in SPSS here, there is a paste option, and you go back to the script. Okay, and you can give your comment whatever you want so that you remember why you ran this command. Okay, SPSS, if you work from the graphical user interface, the problem is if you uh, come back after a month, you will not remember what buttons you were clicking. Okay, but if you maintain this script, it will be useful because you will remember the commands that you ran, why you ran those commands, and so on. So here I'm saying I'm checking the regression from AC to OCB. Okay, and I run this now and see what is the relationship. So my R square is 0.28, 28% variance explained. F of the regression is significant. And again, I see that there are two controls that are significant. And what was my major uh, thing that I wanted to test is that this is highly significant. So I see that there is a significant relationship between AC and OCB. So I have shown that my X is related to mediator, mediator is related to my outcome. And so I do the last part, which is the mediation test. So I bring in my OCB and I also bring in the POS. Okay, and I change the sequence so that POS comes first, AC comes second. And I want to see now what is the direct effect, what is the effect of the mediator on Y. Okay, so now I do the third, which is I test the regression between POS, comma, AC and OCB. And when I run this part, I get my last regression, R square 0.32, F of the regression significant. And when I look at these two, I see that both these paths are, so what is the direct path? The direct path is 0.19. It is highly significant, P less than 0.001. And the path from the mediator to the outcome, okay, is also significant. Okay, so we are seeing that there is a significant relationship. Now what is left to do here is to test whether the indirect effect A into B is significant or not. That is something that you cannot do in SPSS if you are doing it using the regression. So for that, we will go to the process macro, okay, process macro, and we will install it and we will work with the macro that I have given you. So how will you do it? So you go to utilities, okay, go to utilities in your SPSS, and there is a option called as custom dialogues, and then you have install custom dialog. Okay, open this custom dialog and it will ask you for where you want to go. So I'm going to the folder, I'm going to the RNP workshop folder that I have created, And you will see that there is this file process v211.spd. This is the dialog, okay, the process dialog, and we open it. So it says there, in my computer, in my machine, this dialog is already installed. Okay. In your machine, it will not be installed. So you just say it will automatically install it. For me, it is asking, do you want to override? I say yes. Okay. And it will, you will get something like this. It says dialog installed to. Okay. So now when you go to analyze and you go to regression, you will see there is a process that starts to appear. Okay, everybody, I want you to pay attention. You in your analyze, regression, and you will start seeing process. Okay, so when we open it, a window like this opens up, right? Okay, and this is what we are going to work with. Now, along with this, what will also be needed is, in the folder that I have given you, there is a file called as templates. Okay, there is a file called as templates. Now, this process macro, okay, this process macro that has been written for SPSS, it analyzes some specific models, and there are many actually. I think there are 78 models that have been coded in this macro. So this is, if you remember, if you can notice, this is a simple moderation. The conceptual diagram, this is the statistical diagram, okay? Then this is a two moderator, sorry, not mediator. This is a two moderator model. Then there is another, this is called as moderated moderation, okay? And then we come to model number 4. Model number 4 in SPSS, okay? And this is what is the mediation model that we are trying to now test. Okay, so when we go to process here, what is our outcome variable? Our outcome is OCB. Our antecedent or independent variable is POS. If you look at this template, what is the M? M is your mediator. So the mediator is effective commitment. And then you have these controls, so you can introduce these as covariates. Okay? And then look at this. So you have to now work with this. You can change this model number. If you want to do moderation, we'll choose model number 1. Here, we are going to work with model number 4. Okay, model number 4 here. So that is what we use. We will also report bootstrapping. I told you that when you do mediation testing, okay, one of the ways is Sobel t-test, but it has a limitation because it assumes underlying normality. So we also report bootstrap results. Typically 5,000 or 10,000 is good enough. Okay, so I typically report with either 5 or 10,000. So I'm just keeping it at 5 here. And then options, okay, so we want to report the effect size in mediation. We also want to report Sobel test, so it says model 4 only. Effect size is model 4. Total effects, yes, we want to report. Compare indirect effects, we have only one indirect effect, so comparing does not make sense. And I will report my output to 3 decimal. This is continue, and then conditioning. This we will do when we come to moderation. Okay, and then you say okay. Right now, when you run this, you will get the output. Okay, Now look at this. So we have, what do we have in this result? We have, so what does it say? It says model number 4, Y is OCB, X is POS, M is effective commitment, controls are these, sample size, the data that I have given you has 430, R square of AC regressed on POS, which we had also got, by the way. This is the coefficient, it comes out to be highly significant, P less than 0.001. This is the bootstrap confidence interval, lower limit of the confidence interval, 95%, and upper limit. 0 does not lie here, which is telling us that the coefficient is significant. Similarly, OCB is regressed on both AC and POS. Okay, this is what we had also got when we did it using linear regression. Okay, and they are both significant. Now it says total effects model. What is total effects? When you have OCB regressed on only POS, not POS and AC, but only POS. What happens? This is the total effect. The total effect is 0.339. Now you can also do one thing. The A, okay, the path from POS to AC is 0.584. So the A is 0.584. B, that is path from AC to OCB, that is AC to the outcome, is 0.241. So it is B. So what will be indirect effect? We can compute it ourselves. Okay, we can compute this ourselves. So the indirect effect in this case is going to be 0.584 multiplied by 0.241. Okay, this is the indirect effect, the product of A into B. So let us see what it says. The total effect is 0.339. The direct effect is this. And look at this. This is what we have also computed. It is 0.140. Okay, this is the indirect effect. Is the indirect effect significant? Remember, the test of mediation is that the indirect effect in your research, in your paper, in your data should be significant. The bootstrap interval is telling us it is significant because 0 does not lie in this interval. The lower limit is 0.089, the upper limit is 0.198, and 0 is not here. Look at what is normal. What is normal theory test? This is the Sobel's t-test. Okay, the Sobel's t-test is telling us that the coefficient is 0.140. We know that. What is the Sobel's t? It is 5.2. And is it significant? Yes, it is significant at p less than 0.001. So if you add, and the next thing that I want to show here, remember we said C is equal to C dash plus AB. So the direct effect is 0.199, the indirect effect is 0.140. You add them up, you should get 0.339. So 0.140 plus 0.199 is 0.339. So the total effect is equal to the direct effect plus the indirect effect. Okay, so what have we done? We have broken down. Okay, remember in mediation helps us understand the process. That means there is a direct impact of POS on OCB, but there is also an indirect impact of POS on OCB via the commitment of the individual, and that is 0.140. It is significant. So there is a significant mediation effect. Okay, so that is something that you should, that is reported in research paper. Okay, now, so that is our first hypothesis tested, right? We have found out that effective commitment does mediate this path between POS and OCB. Let us now go to the second hypothesis. And the second hypothesis was that psychological contract breach will actually moderate this path between POS and OCB. So mediation done. Now let's come to moderation and see how it is tested. Okay. Also, before I go further, I just wanted to also show you that it is also possible to paste the process command. Okay. So the only problem here is when you paste in SP, I was telling you you should maintain your script. The only problem here is that when you say paste, it also pastes the complete code of the process, and it is like a 3000 line of code, okay, that has been written. So I will just demonstrate that. Once you say paste here and you go back to your script, you will see that a code of about 3000 lines has been pasted in the script. Okay, you can delete this. You can delete this code. You see it says process for SPSS v2.11. Okay, you can delete all of this and this becomes your process command. This syntax is actually already given in this file that I have given you .sps. This is the full syntax of 3000 lines that has been written, okay, for process. So you don't need it here. You can just delete it and you can say this is my mediation analysis hypothesis 1 using, okay. Right. So we have also pasted the command or what we did using process for, and you can save this. Okay, so I'm saving it. I'm saving it as syntax RNP workshop. Okay, that's the syntax that we have now, syntax file that we are creating. Right, so let us now go and do the next thing, which is test our next hypothesis. Now, in order to do that, what you need to do is remember when we said that if I have to test this model, POS and effective commitment, what I need to also do is I need to now, if I am interested in testing how my POS is going to be how POS is going to be related to OCB and how the moderation by PCB, I will need to create a product term POS multiplied with PCB, and that will give me the interaction, okay, that I will like to test. So C1, C2 and C3, because this is all direct effect that we are trying to test. Okay, so what I need to do therefore is I need to, in my data file, I need to create a product term POS multiplied with PCB. Okay, so I go to transform and I say compute variable and I call it as PCB or POS multiplied by PCB, POS X PCB, which is POS multiplied by PCB. Okay, so this is the product term that we are going to do. Okay, and I will paste. So when I go back to my script, I write computing the product, right? And I run this. So my product term has been created, and now I have this product and I can now do my analysis. I go and say regression linear, okay, and I have my OCB, yes, okay, and I have my PCB. Typically, what we do is we actually do, whenever we report uh, moderations, we typically do what we call as hierarchical linear modeling. So you enter your controls as well as the antecedents, and then in your next block you enter the product term. Okay, not this one. We created POS X PCB. So that is the product term that you entered. So in block number one, you just enter these terms, which are the original variables, and then the second is the variable that you have created, which is the interaction term. And in the statistics, you should report what has been the R square change. Okay. And then I paste and I go back to my script and I say, this is hierarchical regression for moderation testing. Okay. And I run this now and I will see the results here. Okay. So what is model one? Model one is when I enter all these variables, and model two is in addition to the variables entered in model one, I also enter the product term. Okay. So the R square is 0.27. Okay. Adjusted R square. Is it significant? Yes. And then I add one more variable and I look at what has been the F change, and F change is telling me that it is significant. So the moment I see this result, I know that my interaction is significant here. Okay, and I will demonstrate it because the F change is also significant. So this was the first model when you had only the controls and your two variables entered. Are they significant? Well, POS is significant, but PCB is not significant. So C1 is significant, C2 is not significant. But don't worry, remember I told you the test of moderation is C3 should be significant. So let us look at this model now. When we enter this model, now we see that this term is actually significant. This term is coming out to be significant. Okay, so there is a significant moderation effect that is happening. Okay, so there, and we'll come to that in a while. But I want to demonstrate before I go further here. I want to highlight one specific thing. If I were to now write this equation, how will I write it? I will say OCB is equal to some constant plus C1 POS, C2 PCB, and C3 POS into PCB plus E of Y, E of OCB. Okay. Now, one thing to note here is how do we interpret our coefficients here? How do I interpret my coefficient C1? What is the interpretation? Now, in regression, when we did not have the product term, we used to say keeping everything else at constant, ceteris paribus. If I change my x variable by 1 unit, y changes by C1 unit. Okay, that was the interpretation of I'm talking about unstandardized regression equation. However, when you look at an equation where you have a product term, when you have this product term, what is the interpretation of C1? The interpretation here is C1 is if PCB is equal to 0 and POS changes by 1 unit, by 1 unit, OCB changes by C1 units. Okay, so what is it? Because there is a product term, I cannot say that if POS changes by 1 unit, because this term will also change then. So I need to tie PCB to 0 and then say if I change POS, how much will OCB change? But remember, in our measurement, we said PCB is measured on a, let's say, a Likert scale of 1 to 7. Okay, it has been measured on a Likert scale of 1 to 7. What is 0 for a scale that does not, that had 1 to 7? Okay, that had only 1 to 7. Okay, 0 is not a defined number for a scale of 1 to 7, and therefore saying PCB is 0, when PCB is 0, POS changes by 1 unit, OCB changes by C1 unit is actually absurd. It is absurd because 0 is not a meaningful number on a scale of 1 to 7. Let's assume instead of PCB, this was age. Okay, what we would have said, if age is equal to 0, POS changes by 1 unit, OCB changes by. Age is equal to 0 means the respondent is not even born. Respondent is not even born, and that person's age is therefore 0. So how can age is equal to 0? So that is an absurd understanding, absurd interpretation. Similarly, C2. How will you interpret C2? If POS is kept at 0 and PCB changes by 1 unit, OCB will change by C2 unit. But again, POS is also measured on a scale of 1 to 7. Okay, 0 is not a well-defined number. And so therefore, in order to make our coefficients meaningful in these, especially moderation analysis, okay, what is done is we mean center. Okay, mean centering is done for both, for all those variables which are continuous and which are not just continuous, where 0 is not a well-defined number. Okay, 0 is. So what do? You actually say POS, PCB mean centered is PCB minus its mean. Minus its mean. So it is now mean centered. And POS minus its mean. So the mean of this now is 0. Okay, this variable is now centered around its mean. Okay, so it will take now both negative and positive values. So now if I regress OCB on, let's call this as C1 dash, I call this as POS mean centered, and C2 dash PCB mean centered, C3 dash POS mean centered multiplied with PCB mean centered plus EY. Now what is the interpretation? I say if PCB mean centered is equal to 0, okay, and POS mean centered changes by 1 unit, OCB changes by C1 dash units. Okay, so what is it that we are doing now? Now we have said that PCB means centered. What does this mean? This variable is actually centered at its mean. So when will this be 0? When PCB will be equal to its mean. Now that is a well-defined number because it lies between the range of 1 and 7. So there is a defined number. So therefore, when you are doing moderation, when we do moderation, we mean center variables where 0 is not a well-defined number. Okay, so that is one reason, because it helps make the interpretation of our coefficients more realistic. Okay. The second reason is when you mean center, you also solve the problem of multicollinearity. Okay. Because these variables, okay, this variable is getting created by the product of these two. Okay. And so it is highly likely that this variable will be correlated with both of these variables. But when you mean center, okay, the problem of collinearity between these variables is also taken care of. So there are people who say that, well, you should do moderation. When you do moderation, you should mean center, otherwise moderation will not come out to be significant. I want to tell you that this is wrong. Okay. Mean centering is done in order to make our coefficients more interpretable and also to take care of the collinearity issues that may occur. It is not done, and I will show you in a while that you mean center or you don't mean center. Okay, this is a very important result that we should take account of. In both these regressions, whether I mean center or whether I don't mean center, okay, the coefficient of the interaction term is exactly the same. So if you had significant moderation in this equation, you will also have it in this equation. And if you did not have significant interaction or significant moderation in this equation, you will not have it even if you did mean centering. Okay, so this is a big myth. This is a myth that we should, whenever we are doing moderation testing, we should do mean centering, otherwise moderation will not come out to be significant. Okay, this is not the reason. C3 actually does not change. So let us look at our data, and we just saw that our interaction term when we had not mean centered was minus 0.13. Let us write it down. C3 came out to be minus 0.13 and it was significant at p less than 0.01. Okay. Now what we will do is we will now mean center. Okay, we want to mean center POS as well as PCB. So the first thing is we want to report what is the mean of these variables. So POS and PCB, what I want to report is mean. So I continue and I paste. Okay, this is the, I will write it down. I am saying I am mean centering POS and PC. So if I run this, I will get the mean of 4.912 for POS and PCB it is. So what do? I go to analyze. Here I go to my data, transform compute variable, and I say POS mean centered is equal to POS minus the mean was 4.9120. 0.9120. Okay, and I paste it, and similarly I say compute, I say PCB mean center is PCB minus the mean was 2.4656, 2.4656, and I paste it, and I go to back to my script, and I'm saying mean centering POS. So I run both these commands because I want to mean center both of these. So my variables are now mean centered. So you see now you have these two variables that have been mean centered. Okay, you can verify in the data file I had already created, but after, even with this, it is the same 1.21, 0.53. So they are mean centered around, they are now centered around their means. The last thing is now we have to create the interaction term or the product term using these mean centered. So we will now say again compute variable, and I say POS multiplied with PCB, and I will call it as POS mean centered multiplied with PCB mean centered. Okay. So I now multiply these two terms. Paste it. And I say creating the product term. Okay, and I run this. Okay, and now we come to our analysis regression. Okay, and instead of, so we go to our block, instead of non-mean centered variable, we are going to include the mean centered variable, and in the next block we will introduce the mean centered product term. We had already written R square change, so that should be fine. And I now write testing moderation using the mean centered variables. Okay, and I run this. Okay, now I want you to focus on this coefficient. Okay, this is, so we get our R square, okay, our F, these will not change, they are exactly the same. Okay, and then look at the coefficients. Look at the coefficient of this term. This was 0.130. I had asked you to write it down. Okay, and you can verify. And what I want to prove here is whether we mean center the variables or we don't, we get the same coefficient for our interaction term. But this is a better thing to do because it makes our coefficients better, and also the interpretation, the collinearity issues are tackled in this. Okay, so what is it telling us? That there is a significant moderation here. Okay, and we have proved by this result. Now we come to doing the same thing using process. So you go to process. Okay, remove, take out. Okay, we want to do OCB. We want to now bring in the mean centered. What is our M? Our M is PCB mean centered. Covariates are these. And what is the model number? The model number is model number 1 here. Okay. Yeah, so I will change it to model number 1. Options. Okay, I want to generate data for plotting. Okay, I told you that we will always plot. So I continue conditions. Typically, we plot, in order to plot, we typically use mean plus minus 1 standard deviation. Okay, I can paste it, but I will also get 3000 line of code in my script, which I will have to now remove. Okay, so I will remove all this piece of code up in process. Okay, and I will say moderation testing. Right, now this is the same thing that we have got. Look at the interaction, and the coefficient is the same that we had also got. Now it says conditional effect of X on Y. What is the conditional effect of X on Y? Conditional effect of X on Y. If you look at this equation, what is the conditional effect of X on Y at the moderator? It is C1 dash plus C3 dash times PC be mean center. Okay, C1 plus C3 M. Right? What is our C1? C1 in our analysis is the coefficient of POS, which is 0.355, minus C3 is 130 times PCB mean centered. This is the effect, conditional effect. Now you can, okay, now you can put in the two values of PCB, that is minus mean minus 1 SD, so 0.678, okay, and you can put in plus 0.678 into this equation. So if we put in minus 0.678, what do we get? 0.355 plus, so if I multiply minus 0.3 with minus 0.678, what do I get? 0.088, and I add this up, what do I get? I get 0.4. Okay, look it up in your output. Okay, this is exactly what we are. This is exactly what we are getting. Okay, so this is called as the conditional effect. And now you can also use this data for plotting. You can use this data for plotting. I have uploaded a Excel sheet where I had drawn it by myself. Okay, so I had copied all these coefficients and then done it, but I will, yeah, so you can just go over this, but you can also do a simple stuff. You can simply plot this, okay, using this. Okay, let me not do it here. Let us do it. So we copy that data from process here, and this is what we get. So this will be pasted in a text, so you go to data and then say text to columns and just say next, next, and finish. And now it has been broken down into 3 columns. Previously it was coming out as a text. So we want to look at when PCB is low, so moderator is low, what happens to the plot? When PCB is high, what happens to the plot? Okay, so to plot any line, there is just 2 points that are needed, but you can also use 3 points. So how do you do it? Insert and then go to this chart. You will have to, as I was telling you, you will always have to plot this kind of a chart in your research papers. So you say add series, okay, add. So I call this as the first series. I say PCB is low. When psychological contract breach is low, okay, yeah, I will edit. And what are my series values? The series values are these. So this is the line. Then I go to add again. I want to add another series in this chart. I say PCB is, sorry, I will say PCB is equal to high. And what is the data? The data for PCB high is this. Okay, so I get this chart, and I can also edit the horizontal axis. So I call this as these 3 numbers. Okay, you will see in the quick layout, I typically, whenever I plot, I really like the 10th outlook layout here. Okay, so you can give chart title, you can give the axis title. So our axis here is y-axis is OCB. Okay, the x-axis is our POS. Okay. And we can delete all these lines. You can edit the chart area. Okay, so you can go to this option here, access options. So it starts, you can make it start from, instead of 0, you can make it start from, so that it looks, yeah. So now you see that the lines are diverging. Okay, you can also play around. Okay, you can make this a solid line, no, sorry, not the fill, but line. So you say solid line and make it black in color. Okay, so now you have a solid line here. Similarly, the x-axis, you say solid line, black color, right? Here we go. And then if you are putting it in your research papers, colored graphs are not put. Okay, so you have to make it black and white. So this changes the line to black and the other also black. So how do you differentiate the two lines? You change the line type. Okay, so now we know that this dash line is when the moderator takes the high value. The solid line is when the moderator is taking the low value. So what does this show? As POS increases, citizenship increases, but the change is lesser when there is a psychological contract breach. When the psychological contract breach is low, then citizenship increases much faster, okay, faster than when the psychological contract breach is there. So this proves that there is a moderation of the relationship between POS and OCB. So this is the proof. This is how you will have to, this is all that you will have to do when you are doing your, when you will be writing your second hypothesis. Okay. Now let us come to the last one, which we are talking about, conditional process model. So the model that we want to test is this kind of a model. Okay, so let us look at the first thing if we want to do it using process. Now the conditional process happens using only the process macro in SPSS. In R, when I do my analysis, I typically use R, and R can do, as in you can do it, but in SPSS, you will have to use this macro if you are trying to do conditional process modeling. So let us explore which model actually reflects our research diagram. So model number 7 comes close to this, but we want the arrow. Yeah, model number 8. Look at this model and look at this model. Okay, so this is exactly the model that we are trying to test. So I go back to my data and I say go to analyze, regression, and process. Okay, I select and I go down to model number 8. Okay, because that's the model that I'm interested in testing. Now, what is the additional thing that I want to add is I want to add W and I want to add M. Okay, so what is my M? M is my mediator. So I add AC, right? Effective commitment is my mediator, right? So that is my M. And what is my W? The W is psychological contract breach. So I go back and I choose my psychological contract breach and I bring it to my proposed moderator. Okay, so that sort of key